Okay, this will be the Chapter 6 notes for first year chemistry on naming chemicals and writing the formulas for them. The first thing that I do in class is I distinguish between ionic compounds, which is one type of compound that we're going to write the names and formulas for, and then molecular compounds. So ionic compounds are generally classified as salts, and that means there's a metal bonded to a nonmetal in an ionic bond that would be transferring electrons from the metal to the nonmetal. And all ionic compounds in this particular chapter will start with a metal or a cation if you want to be a more general, if you want a more general description of what the name or the formula is going to start with. And one of the cations that's kind of strange is the ammonium cation. It's the only polyatomic cation in the chapter, and it actually starts with the nitrogen. So I remind the students that the NH4 plus ion would also be an ionic compound. There are some other quick ways to tell if a compound's ionic, but I basically stick with, if it starts with a cation, it has to be ionic. You might see parentheses in a formula, or you might see more than two elements in the formula, or you might see a Roman numeral written down in the name, or you might see the name ending in ate or ite. But basically you can tell if a substance is ionic because it starts with a cation and then the other part's going to be an anion. On the next slide we have the definition of a molecular compound. It's not really a definition, it's just nicknamed a molecule, and these are covalently bonded atoms together. And covalent bonds occur between nonmetals, and so if the name or formula starts with a nonmetal, and again we have the exception of the ammonium ion, if it starts with a nonmetal it's going to be named in a different format. Another quick way to tell if the compound is molecular, if you don't know if the element at the beginning of the name or the formula is a nonmetal because you don't have your periodic table, you can look to see if it has prefixes and also ends in "ide." So an example would be carbon dioxide. Carbon is of course a nonmetal, and the name also ends in "ide," and so you know it has to be a molecular compound. Dinitrogen pentoxide, you can see the prefixes di and pent, and then again the name begins with the nonmetal nitrogen and ends in the suffix "ide," so you know it's a molecular compound if you wanted to go on the basis of the prefixes and ending in "ide." So we spent a couple days on how to name ionic compounds, and we have a lot of practice problems we do in class. Here are the 4 that we do in the notes. If you have an ionic compound, it comes in 2 parts. You have the cation name first and then the anion name second, and I give the students an ion sheet which has all the names of the ions on it, and all they need to do is find the names of each ion and write them down. So in our first example we have Na as the cation, and that name is sodium on the ion sheet, and then you have another ion called acetate, which is C2H3O2. So the name of this first compound is simply sodium acetate. The next compound we have the NH4 ammonium ion as the cation, and then the anion is CO3, and if they look carefully on their ion sheet they'll find its name is carbonate. In letter C, the example is slightly different because Fe, which is the element iron, it comes in 2 varieties. There's a positive 2 iron and there's a positive 3 iron, and I'll come back to it later to figure out what Roman numeral goes in these parentheses, because we have to distinguish if this compound contains iron 2 or iron 3. The second part of the name is the OH ion. There happens to be 3 of them, but that's not going to affect our name. It's called hydroxide. So this compound is either iron 2 hydroxide or iron 3 hydroxide. And with some reasoning, you can determine that if the compound is to be neutral, then the iron has to have a positive 3 charge because the hydroxides each have a negative 1 charge. So I tell the students basically you need to make the compound neutral, so you need to pick the iron that will make it neutral. And so it's iron 3 hydroxide, and that is the Roman numeral 3 written in the parentheses. In letter D we have the same situation as before, where we have a compound that contains the element lead, and lead has a Roman numeral option of either being 2 or 4, and you can't figure out what the charge is until you look up what the SO4 group is, and that group is called sulfate. Now the sulfate group is a negative 2 charged group, so the lead has to be positive 2 in order to make the compound neutral. So this would be lead 2 sulfate. Now anytime you have a Roman numeral in the name of the compound, it also comes in a Latin name that's on the ion sheet as well. So if you wanted to name iron 3 hydroxide ferric hydroxide, that would be okay. And lead 2 sulfate is also known as plummus sulfate, which is the Latin name for lead 2. On the next slide we do the opposite of naming the compounds, we're going to take the name and turn it into a formula. And there are 3 steps to follow, which I will describe as I'm doing the practice problems. The first thing you need to do is write down the names, or write down the symbols and the charges of each ion that's listed. So copper 2, if you look it up on your ion sheet, it's copper with a positive 2 charge. And bromide, if you look around, you can find it as Br with a negative 1 charge. Now, in order for the compound to be stable, it has to be electrically neutral. So the way we balance out the charges is you do a technique called crossing the charges, which simply means that the exponents, the charges become the subscripts. So there's going to be the 2 brought over to the bromine, and the 1 is going to be brought over to the copper. And so what you end up with is a formula that is electrically neutral. You have CuBr2. You needed 2 negative charges to cancel out the 2 positive charges. Now you don't need to show 1s. So whenever you have a negative 1 charge or plus 1 charge, you don't have to show the 1s. So that's the formula for copper to bromide. Another example shown is aluminum nitrite. Aluminum has a charge of 3. Nitrite has a charge of only negative 1. So we're going to have 3 of the nitrite groups and only 1 of the aluminum groups. And so your formula ends up being Al, and then in parentheses, NO2 with the 3 on the outside. So in step 3, if you look at the steps up above, it says use parentheses around polyatomic ion chunks, is what I call them. A polyatomic ion is an ion that has a charge and is composed of more than 1 atom. So NO2 would be an example of a polyatomic ion. And if you want to double or triple that ion, you have to put the entire thing in parentheses with the number on the outside. Then the last example is barium hydrogen carbonate. Now it looks like it has 3 names, and it obviously appears that way, but if you look on your ion sheet, you can find barium with a charge of 2, and there's an ion called hydrogen carbonate, which has the symbol HCO3. So you're not really looking up the symbol for the hydrogen ion and then the symbol for the carbonate ion. You're actually trying to find the ion called hydrogen carbonate. Now it's given a nickname bicarbonate, but in this example I just called it hydrogen carbonate. Now again, we need to make this compound electrically neutral, and so we can cross the charges. We need 2 of the hydrogen carbonate ions and only 1 barium. And so this is what your formula ends up looking like. Again, you have to use parentheses around the hydrogen carbonate ion or it wouldn't be correct. On the next page, we're going to go through the naming molecular compounds, and you do not need to use your ion sheet for the molecules because you don't have any charges, and they're going to be sharing electrons instead of transferring them. So what we're going to use is prefixes to tell everybody how many of each kind of atom there are in the compound, and I've listed the prefixes from 1 to 10. That's all we're going to have to deal with in this chapter. And then you can follow this general format shown below. You're going to use a prefix, but you don't have to use mono for a prefix if it's the first element. And then you're just going to write down the name of the first element. And then for the second part of the name, you're going to use a prefix no matter what. And then you're going to have the second name of the element, but it has to end in "ide." And it'll make more sense when I do the examples down below. So the first example is N2O5. So we need to tell people there are 2 N's, so we say it's di-nitrogen, and then pent, meaning there's 5 oxygen, so pentoxide. So the name of the element oxygen turns into oxide, or if it was chlorine, it would turn into chloride, or bromine would turn into bromide. Now if the students don't know what the ending is for the element ending in IDE, you can actually find it on the ion sheet. So there's nitride, phosphide, oxide, sulfide, fluoride, chloride, bromide, iodide, hydride, things like that. But basically, you're going to take the word and end it in "ide." And again, you only need to use mono, a prefix mono for the second element. You'll never need mono for the first element, and you'll only need "ide" on the second name. So you only use mono on the second name and "ide" on the second name. So we have the next example. There's 1 C and 1 O bonded together. So we say that the first part of the name is carbon because there's just the letter C, and then we need to say that there's 1 oxygen, so that's called monoxide. So it's carbon, then monoxide. In the next example, we have to use the prefix "for", and that's tetra, and then the element is chlorine. And then we have the prefix for 7, which is hepta, and then the element fluorine has to end in "ide. So it's tetrachlorine and then heptafluoride. The last example is SO3, and the first element is just sulfur. We don't need to say monosulfur because you never use mono for the first element. So it's just plain old sulfur, and then 3 oxygens would be trioxide. So that's naming molecules. Typically the students have a lot easier time naming the molecules because you don't have to look things up on your ion sheet. Then if you go backwards, writing the molecular formulas, the prefixes in the names basically tell you the number of atoms, so those become the subscripts. So we have nitrogen monoxide, so there's only one nitrogen and one oxygen in the formula. For carbon tetrachloride, there's only one carbon and then there's 4 chlorines. And then diphosphorus pentoxide means there's 2 phosphoruses and 5 oxygens, so we say it's P2O5. The last part of the naming chapter we'll probably do in the second semester, so I'll lecture it here, but we're given final exams before Christmas this year, and so we're not going to have enough time to do the naming of the acids this semester, but we'll do it second semester. But like I said, I'll do the lecture here. So acids, if you want to name them, you have to recognize that they're different from the ionic and covalent molecules because they start with the element hydrogen. Now there are some rare exceptions like water is H2O and hydrogen peroxide is H2O2, but when hydrogen's not bonding with just oxygen, you're going to name it with a different system, and it's the acid naming system. So the general format for any compound that's classified as an acid is H bonded to X, where X represents some anion. Now there are 2 general types of acids. Some acid names or some anions that bond to the hydrogen end in the suffix "ite" or "ate", and that's going to be classified as what's called an oxyacid, which means they're going to have hydrogen, oxygen, and some other element X in the formula. Those are oxyacids. So if you don't want to look at the name of X as being, sulfide or sulfate or phosphide or phosphate or whatever, you can just look to see if there's if there's oxygen in the formula. So it's classified as an oxyacid. And then there's the other types of compounds where X just ends in the suffix "ide", and that's going to be classified as a binary acid, and that means that the acid just contains 2 elements. It's hydrogen and then some nonmetal that's not oxygen. Now there is a goofy exception to this, and that's the acid that contains the ion cyanide. Cyanide is capital C and capital N bonded together. So cyanide ends in "ide", but there's actually 2 elements. So hydrogen cyanide would be HCN, the molecule. But when you want to name it as an acid, you're going to have to name it using the binary naming system because it ends in "ide". I probably won't have the students name that one since it's so weird. Now, here's the techniques for naming acid. You have to figure out what the name of the ion X is, and if it ends in "ate", like sulfate or phosphate or nitrate, then you're going to name the acid with some word that relates to the ion and then "ic". So if it's, let's say, nitrate, you're going to call it nitric acid, or if it's sulfate, you're going to call it sulfuric acid, or if it's carbonate, it's carbonic acid. If it ends in "ite", you're going to change the ending to "us. So if it's nitrite, it turns into nitrus, or if it's bromite, it's bromus, or fluorite, it's fluorus. So you just do a little name change. The ending is going to be changed. So for our first example down below, we have H2SO4. So if you look up SO4 on your ion sheet, it's called the sulfate ion. So the "ate" word turns into "ic". Now it's kind of weird for the sulfate ion. They throw in an extra syllable. So instead of saying it's sulfic acid, as our general format tells us, you actually add the syllable so it's sulfuric. So you get the whole name for sulfur in there, sulfuric acid. For the next ion, it's PO3, which is phosphite, and so you're going to actually call this substance, the "ite" turns into "us. So you would think it's phosphus acid, but yeah, again, you add an extra little syllable in there, so it's phosphorus acid. So sulfur compounds or sulfur containing acids and phosphorus containing acids always add an extra little syllable. So I remind the students, I say it this way, I say PS, you might have to add an extra little or an extra little or syllable into the name of the acids. I usually don't take off for spelling errors in first year chemistry, but we use sulfuric acid and phosphoric acid and phosphorus acid and other acids containing sulfur and phosphorus so much in class that the students basically get the hang of of adding these extra little syllables. But anyway, our technique is still the same. You're going to look up the name of the ion, and if it's ate, it turns into ick. If it's ite, it turns into us. So let's continue on with example number 3. We have the NO3 ion called nitrate, so it turns into nitric acid. CO3 is carbonate, so it turns into carbonic acid. Now, the accent is actually carbonic acid. Carbonic acid is found in soda. It gives the soda its fizz. But anyway, so it's the carbonate turns into carbonic. The next ion is acetate, and so it turns into the ending ic. And again, there's a little pronunciation thing. Instead of acetic acid, it's called acetic acid, and acetic acid is vinegar. It is found in vinegar. And the last ion, ClO2, is chlorite, so the name of this acid is chlorus. So, all you need to do to name acids is look up the ion stuck to the hydrogen and change ate to ick or ite to us. Now what happens if you look it up and it ends in ide? Well, if it ends in ide, there isn't going to be any oxygen in it. And you have to put the prefix hydro in front of the name and then change it to ick. So we have the plain old ick, and then we have acids that are actually hydro-ick. And the hydro-ick acids don't contain any oxygen, they're binary acids. So let's name these acids down below using this hydro prefix. So if you look up S, it's sulfide, so it's going to be called hydro, and then just like we did before, we're going to add that extra little syllable, sulfuric acid. So it says hydrosulfuric acid for the answer. For the next example, we have Cl, which is chloride, so it's going to be called hydrochloric. For HF, the F stands for fluoride, so it's hydrofluoric acid. So ate turns into ick, ite turns into us, and if it's ide, you have to say hydro and then something ick. So naming acids is just basically a changing of a suffix, or adding hydro and then ick. If you're going backwards and writing the formula, you have to first determine what the formula of the anion was. So if the name starts with hydro, you know it's going to end in ick automatically, and the name of the anion used would be the ide name. So therefore, it's classified as a binary acid, and there's only hydrogen and then one other nonmetal in the formula. Now, the subscript on the hydrogen, this is very important. The number of hydrogens that you're going to have in the formula has to equal the anion's charge. You have to make this compound neutral. So we're going to look up the names of hydrobromic acid, whatever that ion was. Well, if it's hydrobromic, you know it must have come from just the element bromine, and if you look up its symbol, it's Br with a -1 charge, so you only have one H in front. Hydroiodic came from iodide, and so the iodide ion is the letter I with a -1 charge, so you need one H in front, so it's Hi. And then hydrosulfuric came from sulfide, and we know that sulfide has a -2 charge, so your formula is H2S. And the last page that we have here, if the acid's name ends with ick, and there isn't any hydro in front, then you know that ick came from the ion that ended in ate. So therefore we know it's going to be an oxyacid, so there's going to be hydrogen, an element, and then there's also going to be oxygen in there. So again, we have to make the compound neutral, so the number of hydrogens in front equals the anion's charge. So we're looking at perchloric. It came from perchlorate, and when you look up the ion, it's HClO4 for the formula. ClO4 has a -1 charge, so you need one H in front. Oxalic acid came from oxalate, and that ion has a charge of 2, so we have 2 H's in front, and then the oxalate ion is C2O4. So that's ick coming from the ate ion. Our last situation is an ion that, or the name of the acid ending in us, and so that means that it must have had an ion that came with the ending ite. So if you see hypochlorous, it came from an ion called hypochlorite, which is ClO with a -1 charge, so there's one H in front. Nitrous came from nitrite, and the formula for that ion is NO2, and again it's -1. Sulfurous came from sulfite, and so the sulfite ion is SO3, and since it has a -2 charge, we need 2 H's in front. So that's basically how you name acids, and again we'll have that in the second semester.